So now we are going to discuss about some problems based on the LTI system properties. So you'll get questions like they'll provide you some impulse responses, and from that impulse response you have to identify whether the system is memoryless, causal, and stable or not. Okay, so I'm going to start with the first question. This is a continuous time signal. H of t is equal to u of t plus 1 minus u of t minus 1. So u of t plus 1 means it's a step function, starts at minus 1. So that's what it represents the graph. Whatever the question you are getting, first plot the graph. Okay, so it is starts at minus 1, and like you can see that minus u of t minus 1, that is your signal ends at plus 1. Signal is ending at plus 1. Amplitude is 1. Okay, so this is what h of t. This is what h of t. Now we have to check for memoryless first. So what is the condition for memoryless? It's a continuous time system. So condition for memoryless is h of tau is equal to 0 for tau not equal to 0. You are going to get an finite or a positive amplitude only when your tau value is equal to 0. Only that case you should get an amplitude. For all other values of tau, h of tau should be 0. So the signal whatever provided is h of t. Now replace t by tau, you will get h of tau. Now you just see for other values of tau also, are you getting some amplitude? You have amplitude at tau is equal to 0. I agree. But you can see that for tau less than 0, similarly for tau greater than 0, for both the things you have an amplitude for h of tau. The meaning is the given system is not a memoryless system. I can directly write that. Okay. Now come to the next case. Okay, you have to check causality. For a causal system, what is the condition? Once again, we'll go back to the theory and see. It is h of tau is equal to 0 when tau is less than 0. Okay, tau is a negative side tau value, that is minus 1 or minus 0.5 or minus 2 or minus 10. For all those values, your h of tau should be 0. That is a condition for causal system. Is that agree for this? No, you can see that even though tau is less than 0, I have amplitude. So can you write that the given system is non-causal system? Okay, so two things over. Next, what you need is you have to find out whether the given system is stable or not. Okay, so this is the equation for stability. Summation minus, not summation, integral. Integral minus infinity plus infinity h of tau. It is modulus value. Okay, modulus value of h of tau d tau. Do you want to integrate from minus infinity plus infinity? My signal starts at minus 1 and ends at plus 1. So this I can directly change it to minus 1 to plus 1. Okay, so integral from minus 1 to plus 1. What is the value of h of tau? H of tau's absolute value is 1. So can I write it as 1 d tau? 1 d tau. Now integrate it. 1 d tau means tau is your integrated answer. Tau, it is from this thing. You write the limits. It is minus 1 plus 1. So upper limit minus lower limit. Are you getting 1 plus 1? It is equal to 2. Are you getting a finite answer? That is, it is less than infinity. We are getting a finite answer. The meaning is the given system is stable. So we completed the first problem. The system was not a memoryless system. It was a non-causal system, but the system is stable. Okay, so now we will go for the second problem. Here also you have to check for all the three conditions. You can see that the given system is given impulse response is for a discrete time system h of n. Okay, first plot it. You can see that it is u of n minus 1, that is your signal starts at plus 1 and goes up to plus infinity. So that's why at 0 amplitude is 0 only. My signal starts at plus 1. So n value is 1, 2 power 1, that is 2. Next, at 2, 2 power 2, 4. 2 power 3, 8. Like that it goes on. It's a gradually increasing graph. Okay. So this is my signal is. Now, from this graph itself, can I tell whether it is memoryless and causal? You can see that this actually in this case, this is discrete time. So we have to tell as h of k. Okay. So I have to write instead of n, I should write it as k. So now see, for a memoryless system, I should get an answer like this. H of k is equal to 0 for k not equal to 0. But you can see that for k is equal to 1, k is equal to 2, 3, up to plus infinity, I have h of k value. So the given system is not a memoryless system. Okay. So the system is not memoryless. So first condition over. Now we will go for causality. What is the condition for causality? It is h of k should be 0 for k less than 0. Now you see, k less than 0 means negative sign. For k less than 0, are you having any amplitudes? No, we don't have any amplitude. The meaning is this impulse response satisfy the causality condition, that is the given system is causal system. It is causal system. So second condition also over, second half also over. Now we will go for the third part. Third part, we have to find out whether the given system is stable or not. What is the equation for stability? Stability, this is discrete time system, so I should write it as summation k from minus infinity to plus infinity modulus value of h of k. Okay, it should be a finite answer. Now, this equation I can write it as, I don't want to start from minus infinity because my signal starts at plus 1. So k from 1 to, it ends at infinity. So 1 to infinity, what is h of k amplitude? Actually, you can see that h of k amplitude is keep on increasing. So I'm just writing it as h of k only. Okay, now give different values for k. If I'm substituting k is equal to 1, h of k amplitude is 2. If I'm substituting k is equal to 2, my amplitude is 4. So 2, it's summation. So I'm expanding the summation. So 2 plus 4 plus 8 plus etc. It goes up to infinity. Okay, this goes up to infinity means this summation leads to an infinite answer. That is, the given system is not a stable system. Okay, so this is how we have to do for a discrete time system. So now we'll discuss about the third problem. Okay, so in the third problem, it's a discrete time problem. This impulse response only. H of n is equal to 4 power minus n u of 2 minus n. First, we'll discuss about what is that u of 2 minus n. How you will write u of 2 minus n? I can rearrange it as u of minus n plus 2. Isn't it? So u of n minus n plus 2 means you can see that you have time shifting and time scaling in the same equation itself. So you know that due to the precedence rule, you know that first we have to do the time shift, then we have to go for the time scaling. So how you will calculate u of minus n plus 2 is, first you have to draw u of n, then u of n plus 2. U of n starts at 0, ends at plus infinity. So what is u of n plus 2? U of n plus 2 means 2 times advancing, That is, the signal will start at -2 and ends at plus infinity. So you got that what is u of n plus 2. Now scale it. U of minus n plus 2. Minus n means you are doing the complete mirror image. That is, whatever is there in the positive side, it comes at the negative side. So what will happen? Previously, your signal started at -2, ends at plus infinity. Now, at present, after the time scaling, your signal will start at minus infinity and ends at plus 2. Okay, this is u of minus n plus 2. Now you can see that it is not, our question is not u of minus n plus 2. It is multiplied by some other factor. It is 4 power minus n. So if I am substituting different values for n, I will get a gradually decreasing graph, and the graph will end at, or the signal will end at plus 2. Okay. So this is how the graph I am getting after plotting this h of n. So from this graph, now we will see whether the system is memoryless or not. What is the equation for memoryless system? It is h of k. This sequence, if I am replacing n by k, I'll get h of k. H of k should be 0 for k not equal to 0. But you can see that for negative values of k as well as for positive values of k, you have h of k. The meaning is the given system is not a memoryless system. So I can tell that it is not a memoryless system. So the first subdivision over. Now we'll go for the second subdivision. That is, we have to check whether the given system is causal or not. What is the condition for causality? That is, h of k should be 0 for k less than 0. But that condition is also not satisfying. You can see that for k less than 0, I have amplitude. My signal starts at minus infinity. So the given system is not a causal system, or I can write that this is a non-causal system. Okay, so second subdivision also. Now we have to see whether the given system is stable or not. What is equation for stability? Stability is summation k from minus infinity to plus infinity modulus value of h of k. Okay, so do you want it from minus infinity? Yes, my signal starts at minus infinity, but it ends at plus 2. So I can write that k from minus infinity to 2 modulus value of h of k, that is, can I write it as 4 minus k? Sorry, 4 power minus k. 4 power minus k. Okay, so I'm writing this equation. Even though you are not writing also, no problem, but you can write in that way. Okay, 4 power minus k. Now you see, it is like that my lower limit is not equal to 0. It is minus infinity. First, interchange the limits. You know that for a summation, you can interchange the limit without changing the sign of the equation. So I can rearrange this equation as summation k from 2 to minus infinity 4 power minus k. But still I have a minus infinity there. How to cancel that minus infinity? You can substitute k is equal to minus k. If I am substituting k is equal to minus k, then this thing will become k is equal to minus 2 to plus infinity 4 power plus k. Okay, so now I don't have that minus infinity problem. Now my this thing is summation is from k from minus 2 to plus infinity 4 power k I am getting. Now you just see my lower limit is not 0. If lower limit is 0, I can directly go for the substitution. Even though my lower limit is not 0 also, you can see that if you are substituting some values for k, like you may get it like this: 4 power minus 2. Okay, I'm substituting k is equal to minus 2 first. So 4 power minus 2 plus 4 power minus 1 plus 4 power 0 plus 4 power 1 plus etc. up to 4 power infinity. Obviously, that answer will be infinite only. Okay, so the given system is not a stable system. Okay, so this is for the third question. System was not a memoryless, non-causal, it's not stable also. Now we'll go for the fourth problem. In the fourth problem, here you can see that this is a continuous time impulse response, but I wrote it as e power minus 4 modulus of t. This is t, small t. Okay, modulus of t. First tell me what is mod x. Mod x or mod t is, it is equal to t for t greater than 0. That is, if t is positive, then mod t is t only. If t is negative, then mod t will be minus t. Isn't it? So I can write like this, mod t is equal to plus t for t greater than 0. It is equal to minus t for t less than 0. Now I can plot the graph. So for t greater than 0, I am getting it as t only. That is e power minus 4t I will get. This side will be, positive side will be e power minus 4t. E power minus 4t. So e power minus 4 or e power minus means it's a gradually decreasing waveform. I can represent like this. Now we will see t less than 0. At t less than 0, it is mod t is equal to minus t. So e power minus 4 minus t, that is e power 4t, e power plus. Then it is a growing exponential. That is why it is growing like this. So this side is e power 4t. This side is e power minus 4t. So my graph is like this. From this graph itself, I can write that. See, I have h of tau value is not equal to 0 for tau not equal to 0. Isn't it? I should get as h of tau equal to 0 for tau not equal to 0. Tau if I am substituting negative, I have an amplitude. Tau if I am substituting positive, I have an amplitude. Obviously, the given system is not a memoryless system. So the first part over. Not a memoryless system. Similarly, I can see that like I have amplitude for h of tau for tau less than 0, that is tau negative and tau positive. Obviously, then my given system will be non-causal, because for causality, what is the condition is, it is h of tau should be equal to 0 for tau less than 0. But in this case, for tau less than 0 also I have amplitude. That's why I wrote it as this given system is non-causal. Okay, now I'm going for stability condition. So, but here you can see that actually my general equation is from minus infinity plus infinity and all, but I have to split it into two integrals because I have some amplitude, I have a growing exponential for negative side, I have a decaying exponential for positive side. That is integral from minus infinity to 0. Okay, minus infinity to 0. It's a growing exponential which is e power 4t. E power 4t, not t, it's tau, isn't it? So e power 4 tau d tau plus integral from 0 to plus infinity, it is e power minus 4 tau d tau. Integrate it. After integration, you will get an answer as 1 by 2. Apply the limits, you will get the answer as 1 by 2. That is, you are getting a finite answer. That is, the given system is stable. Okay, so this is how we have to do the LTI system properties problem. So whatever the question they are providing, first try to plot it. Okay. Then you can see that whether your signal is having values for tau less than 0, tau greater than 0, or k less than 0, k greater than 0, that you can easily see, and you can tell that the given system is memoryless or causal, that easily you can find out. Okay, thank you.